With this video, we begin a discussion on related rates, and we'll start from some AP multiple choice questions. When the area in square units of an expanding circle is increasing twice as fast as its radius in linear units, then what is the radius? So we start with our circle, and the area of the circle is increasing. The area of the expanding circle is increasing. Now dA dt would give us the rate of change of the rate of change in the area of that expanding circle. And we know that that rate is increasing twice as fast as the radius. And what that really means is twice as fast as the rate of change of the radius, not as the radius itself, but as twice as fast as the rate of change of the radius. The rate of change of the radius would be 2 dr dt, and so we have this identity that dA dt is equal to 2 dr dt. When that is the case, we want to find out what the radius is. So we need an equation that's going to relate together area and radius. And no big deal, that's a equals pi r squared. We're going to differentiate both sides with respect to time. On the left side we get dA dt. On the right side we're going to get 2 pi r dr dt. Now the calculus is done, and we can do one of a number of things, but we're trying to solve for r. So we can apply the constraint here that dA over dt is equal to 2 dr dt, and we plug that in for dA dt on the left side. And now we can cancel dr dt on both sides. We can cancel 2 on both sides, and we'll be left with 1 equals pi r down to one variable, and we simply divide both sides by pi, and r is equal to 1 over pi. And that does it for this problem. We'll go on to the next. This next problem comes from 1973, AB 26. We have the radius r of a sphere, and it is increasing at a uniform rate of 0.3 inches per second. The radius is increasing at a uniform rate of 0.3 inches per second. We write dr dt is equal to 0.3 inches per second. Next, at the instant when the surface area S becomes 100 pi square unit inches, what is the rate of increase in cubic inches per second in the volume? So at the end we see what we're looking for is the rate of increase of the volume. So we want to know what dV dt is when S, the surface area, equals 100 pi inches squared. So we have the two rates that we're working with, dr dt and dV dt. We need a formula to relate them together, and that would be V equals 4/3 pi r cubed. And we're going to start by differentiating both sides with respect to t. dV dt on the left is equal to 3 times 4/3 times pi r squared. Don't forget the dr dt. And that leaves us with 4 pi r squared dr dt. Now dV dt is what we're trying to solve for here at the instant when the surface area is 100 pi inches squared. There's a couple of ways we can go about this. We know that the formula for surface area is 4 pi r squared is equal to 100 pi. We could solve that for r and plug in and simplify, but you might notice that our expression already has 4 pi r squared in it, so we can just simply replace that with 100 pi. And we'll plug in that dr dt is 0.3, so that will give us 30 pi inches cubed per second. And so that does it for these two problems.